Welcome back everybody to How to CAD Almost Anything, the Disney Edition Session 6. We are at the end of the journey. This is the last session, at least of the asynchronous portion, right? There's always going to be the in-person one. And while I'm a little bit sentimental about it, I also think that we have some of the best projects coming up on this session. As usual, we look at our front slide in here. We've done a lot of things throughout the last 6 sessions, last 5 sessions. The monorail, the train, the genie's lamp, the green aliens as opposed to the Mickey. Mickey was too difficult. The scream canisters, the Luxor Junior lamp, a commemorative coin, a mug, which means that today we're left with two more things, which are going to be quite fun. One of them is Spaceship Earth. That's going to be the second half of today's video. That's quite a fun project, and I definitely encourage you to check that out because it looks a lot into the geometry of how to make something that is a geodesic sphere. That's what it is. And the other one is this. This is called the Astro Orbiter. And while I don't think, well, actually, this picture looks a little bit more complicated than what it actually is, right? This is the Disneyland. We're gonna cut the Magic Kingdom version of the Astro Orbiter. And I'll explain this in a moment, but the reality is that while this CAD is not particularly difficult to do in terms of like the CAD itself, right? Like the model, it's more about the creativity of how you put the assembly together. And that's gonna be fun as well. So let's go ahead and get started. So yes, today's agenda is very simple. It's really about Spaceship Earth and the Astro Orbiter. And eventually, once we're done with that, we're just gonna put everything together into the theme park that we've been building, and that's always all gonna be available on the website afterwards. Yeah, so last time was this, the genie's lamp, and something that ended up being too difficult, which is the Mickey statue. Even the green aliens that we tried, that was also very difficult. And that is perhaps a reflection of how SolidWorks is a difficult software to work with when you want to do surface modeling like this. Maybe something like Blender would be more appropriate in a circumstance. So yeah, just something to know, but we tried, we did our best. And this is today. Spaceship Earth, the second half, and what we're gonna start with today is the Magic Kingdom Astro Orbiter. And I think that looks pretty, it's not a terribly difficult model to do. Like, I would actually anticipate that the part that might take a lot of time, just if you wanna go very detailed wise, it's gonna be the little rockets. Otherwise, this structure in here, like, we're gonna keep it relatively simple. Like, yeah, I'm not gonna add like those details, but definitely, yes, the holes and like these beams in there. It's gonna be like a pretty, and then like the frame that goes around it. So I think it's gonna be a pretty representative, model. But it's more about getting this thing to work. So the way this works is that this thing rotates around, and while this thing rotates around, the version that I want to cut is such that these rockets go up and down, and I think we can do that. So yeah, so let me go over to here to SolidWorks. Let me open it here. And to explain exactly, I have a bunch of pictures that we're going to use for the modeling, but I want to start today with a part that I will explain before I start doing the classic speed cutting process, which is just explaining how the mechanism is going to work. And I have a picture. I apologize. Yeah, that's fine. I apologize for the quality. This is my drawings in here. And it's such that so this stick in here, that would come to represent, say, one of these sticks in here, and you can imagine the rocket being there. And the idea is that if this stick is hinged to a fixed point there, and then you have a circle, and this circle is connected via bar, that's a matter. But as long as you can make this circle work, then it has a little knob that slides through this bar and there. The idea is that if as I rotate this, because of the sliding area, this bar will go up and down. That's the overall concept. It's similar to how you make like a honestly like a piston engine work. So the idea is that then if you have a bunch of these that are linked to a central gear, then you can make all of these move up and down simultaneously. And so that's what we're gonna go ahead and CAD right now. I'm literally gonna come here, and I'm gonna start actually by making that because I think that's gonna be the most the heart of this project, honestly. So I'll start in here and I'll draw a circle. And by the way, I'll probably use this circle later to define pretty much like the entirety of this project. So I'll call this maybe 200 as an example. By the way, I do want to go here. So this is coming up and down from here. So it's going to go down, up, just like, so it's like that circle that we're drawing would represent this one right there. So I'm just going to draw that circle and I can give it some volume, maybe 5, the classic. And then what I'm gonna draw in here, and this, by the way, it's still rather experimental, right? Because I'm gonna try this out, this concept first as we go. So this is gonna be a rather coarse like drawing. Don't get too excited about how this is gonna look like. But the idea is that I'm gonna move this like right here, so I can even define. Say I want that. I'm gonna make that like 30. Make that 20. I'll make that 10, such that I'm gonna make another. So this area here is gonna represent the hinge along which this is gonna go up and down. So maybe I might change some of these dimensions in a moment, but we'll see. So this is I made that 5. Okay, that's good. But then we need to draw the one where the circle is rotating from. So I'll bring this maybe to 50. Did it change? It's not even, oh, the invalid solution. Why? Why did you find an invalid solution? Maybe I should probably delete. I wasn't paying attention when I was drawing this, so there's probably something that I drew badly, but it's okay. We'll just do it. We'll just do it again. Maybe I'll just draw it simply like this. Two rectangles that we're gonna draw like that, very simply. At that point, let's make that 15, 20. Okay, let's do that. This well and 5. There we go. It's fine. Good. And you'll see what I mean with all of this in a moment. So I'm gonna maybe extrude this one upwards by, I do not know, maybe let's do that. Let's say 15. And the idea is that now I'm gonna do a sketch in here. And this we're gonna do a mirror, by the way, or we're gonna do a circular pattern, I mean. So we can have, I'm imagining 8 of these spinning guys. We can make that 5. We can make that 5 as well. Extrude, I'll say, so that should be 20. I might actually make this 15, and you'll see why in a moment, because I'm gonna come back here. I'm gonna edit this such that this is 15 as well. There we go, so it's all like very uniform, right? Perfectly. And now I can go here to fill it and do boom, just like that. I just for simplicity, I'm not gonna do a hinge in there. Like that would be too much, but I'll leave it like this, like that. Boom. Okay. So now we got the part where the bar is gonna be hinged from. Now what we would need, actually, I'm gonna save this. I'm gonna call it Astro Orbiter 1. Very creative name, but it will help when you do build the assembly later. And I do want now the place where the circle is gonna be rotating, the one like that's gonna guide the bar. And this one, I'm gonna draw it such that it's gonna be a little bit in front, doesn't be there. And also the magic of this process, by the way, is that like we can make it work. It doesn't need to be perfect. And you'll see what I mean by that in a moment, in the sense of like I don't need to make the whole gear mechanism. It just has to be functional. And hopefully that's gonna make sense in a moment. I can make it be 10, 30. That could be 15 too. Yes, it's about the same. And maybe I would do a little bit significantly more, I would say. Maybe this I would make 30. It has to be significantly more. So I come here to sketch, and I can go downwards. Say by 5, that's fine. And I always come back here with another 5. And we're gonna hinge it such that that's gonna be 5 as well. Boom, fill it. So then we're gonna have a disk in there that's gonna be doing some of this motion. Actually, by the way, I think we may need to move this like one more unit towards there. So I'll do that right now. No, not here. I need to actually delete this line for a second. I know it's not gonna like it, but that's fine. And now, yes, I'm gonna come back there. I'll make this and that perpendicular. I'll make that 5. And I'll make this 30 as well. And now we're back where we started. Okay, good. So very, very easy stuff for now. I'll go here to file, new part. And now what I'm gonna do is a quick circle in here. And I can also like pretty this up, like make it thinner. Like I'm not too interested in like now it's just to get the proof of concept. And if the proof of concept works, then yes, we can get fancier. Even though like nobody's gonna be seeing this design. Go here for 5. And now the idea is that now go here to sketch. I go over here, say 20 is an example. I'm gonna also make that be equal to 5 as well. So I'll just and I'll extrude this by 5 as well. Boom. I'll save as Astro Orbiter 2. Now the whole concept is that now I'm gonna start building the assemblies. I'll make new assembly. I'll bring Astro Orbiter 1 first. And now insert component Astro Orbiter 2. And what I'll do is I'll mate, say first this face and this face. I think that's the correct direction. And then I'll make this face and that face. By the way, one thing I could do, which I think I'll end up doing, I want that to be concentric, very good, is that I can also get rid of, I'm gonna save this, call it Astro Orbiter Assembly. And the bottommost point that this is gonna come to is here, which means that we just need to be, so I'm gonna save this thing, and I have some ideas of some things that I want to implement. Primarily, the thing is that, yes, so that means that it's gonna go up, it's gonna go, and then our bar is gonna go as high up as that. I think this is a pretty good, and in terms of how this is gonna work out. Yeah, and the height actually of this thing is just spot on. Maybe I could change it such that it doesn't look as. I'm gonna go here to this piece, maybe here. I'll change it to 4.5. Meanwhile, I'll go here to sketch, and I will just draw a rectangle that's gonna come like this, and I'm gonna do an extrusion. There you go. So that way we have like a good old, maybe I can start to decorate some of this stuff. 2.5. Actually, I'll just leave it as is. It's fine. But the idea is that now I'm gonna create one more piece. There we go. File. Actually, now that I think about it, I'm gonna get rid of this. We'll edit this part, and I'm gonna get I'm gonna extend this to be all the way up here. Now, yes, extrusion, all of them. Now, yes, I think I'm happy. So it's like we're creating a disk. I think it's gonna go well. So now let's go here to file, new part, and this is gonna be like that bar that keeps on. So go here to file, sketch, front plane. You just do a big rectangle. The overall length of this, I'm not too worried yet because I'll make it pretty and whatnot. But maybe for now, let's go for, let's say, 100 as like the original sliding portion of this. And then this has to at least be 10. You'll see why in a moment. And then the area where I want the hinge to be is going to be there. So first, let's extrude this upwards by 5. Now, I'm going to go here to sketch, 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 boom. A bunch of things that I want to do. First, I'll go here to 5. Let's do circle also worth 5. Let's extrude 5 in that one direction, 10 in the other one. That way it goes right where we want this to be. And then I'm going to do a big slot in this area. I'm just gonna come in this direction. It's gonna come in this direction. I can say, right, I want this slot to be, I could well maybe make a line that goes like that. Another line that goes like this. And I say, right, oh, I'll say, right, I want these two, this one, and I want to be equal. Then this one and this one to be equal to, which they should. Oh, they will, and I want say that to be 5. Actually, perhaps a little bit more, 10. So now I go to my friend the slot, I click these 2 points, and I'll make this be a 5. And now I'm gonna extrude, boom, and we can, there we go. Wait, fill it with I mean 2.5 is fine. There we go. Okay, perfectly. I'm gonna save this and download as Astro Orbiter free. So why all of this trouble? Because now's the moment of truth. We go here to the assembly. Yeah, that's fine. Yeah, so that is slightly higher up, which is what we wanted. Insert components, and so there like this. And now I made this guy like that. It's fine. Made this face. Boom. So this is allowed to go like that. And now we're gonna make, actually I'm gonna bring this upwards like that. And I'm gonna make this face and that face to be always tangent. So what does this achieve? Is that now, hey, it is doing the reciprocating movement that we were intending this to do. Oh, that's fantastic. And depending on your original position of the, and now what I can do now that I know that also the overall dimensions of this stick are fine. Actually, I can go back to the stick and make it slightly shorter. Like I can make this a 70 instead. And I think that would still, we go to the assembly, I think this would, no, it doesn't work. I need to make it. Um, let's do it late. 80 would probably work. Okay, that's good. So now we're gonna, now that this is looking good, we can beautify this design. It's gonna be quite simple to do. We'll save the document. And now go over to our original piece. Then I'm actually gonna make 2.5. 5, good. We'll see how much of this it's able to like do a circular pattern of. So let's go here to our friend circular pattern. And features we're gonna do well this one, that one. So pretty much everything but the original one. Around here. We don't want 20, we want just 8 of them. So it's gonna be an 8, like an easy. Oh, why is it geometry pattern? I don't want geometry pattern. Let's see. Okay, good. And you have a nice pentagonal design in here. So now I can make a core out of all of the area that I have in here. If I can probably get rid, if I go back to that first fillet, I can get rid of this one. And I'll just merge all of that. What I'll end up doing, I'll go here to sketch. And I'll just gonna very tidily. Actually, I could just, no, no, it's not exactly. So it's a nice looking polygon. I can bring this upwards up to surface here. Boom. Now we have a nice, cool looking structure in there. And then yet we can start adding like a bunch of like chamfers like everywhere. For instance, let's see. Yeah, done. So like 5. So this is gonna be going downwards like this, by the way. I think that's too much. We'll do say 2.5. Then as for chamfers on those edges, we can do the classic, say 1. But no, we're not quite done, as you'll see in a moment, because I do want to add a central gear that you'll see soon. So at least a part of this is gonna work. All right, here, there. I click on save. But I think this is probably fine. I could melt it. They look good. Nah, I like it. I like it like this. Okay, save. Now, actually, I'm just thinking. Mm, mm, mm. Right, I think what I'll do, one last crucial step in here is that this thing is going to be rotating around like a central hub. So I think actually this piece in here might end up being its own piece. So with this, I might make that a 30 and just extrude downwards through all. Now you have a nice little ring structure. So this is gonna be rotating around like something else. Um, I'm gonna save. Maybe for the purposes of now, I'll go here to File, New, Part. That's completely fine. Sketch. Uh, I'll probably work off. I'll see how I end up implementing this in a moment. Yeah, then it's fine. Like this one, this part that I'm designing now, I don't care much how it ends up looking. But you'll see what I mean in a moment. I'm just gonna make this 30 and I'll make that a 50 as an example. Good. I'll save as uh, I'll save it like all of this stuff. Yes, this is the fourth part technically, but I will change many aspects related to this soon. So now we go to assembly. Yes, a lot has changed in here. So now it's a function of adding a ton of parts. So I'm gonna do that right now, and I'm gonna add them manually. By the way, like I'm not interested in any like I don't want to do any sort of patterns because I want all of these to act independently of each other. And that phase, that's fine. So this is gonna be a little bit of a pain, but well, we'll do it slowly. Here, there's no rush. Okay, but I want this to be on the opposite direction, like this. Then I'm gonna make this face and that face. Boom. At least that's a good thing about doing 8 of these and not like a zillion. Well, that would have been a lot more work, right? You see, so this is like the more where you have to be creative. Otherwise, the rocket is probably where most of the time is gonna end up falling. And as usual, as you can probably anticipate from such a design, we'll be able to do. You can probably make a nice animation out of this. This is probably gonna be something worth animating. You can probably put like a torque motor and make this go around in circles. And there we go. I'm gonna make this face and this face in here. All right, we have 3 more to go. I know it could be copy pasting a lot of this stuff, but the only positive thing is that maybe a fun fact. I do not remember the word in Japanese, but there's a word in Japanese that goes that is related to product design that concerns that whenever you design an object, such as this one, where it's a very obvious the way you assemble it, right? Like you have that knob in there, like right, what I mean to say that sometimes when you design pieces with symmetry, such as this one right there, it doesn't matter which side you put it on from, it would work, right? Because they are identical. Meanwhile, with that one, it kind of does matter if the knob is pointing in the correct direction or not. Very good. So I'm just putting all of these guys in here in their place. And what I like a lot about this is that all of the gears are kind of in like different positions right now. Which means that now I can start inserting this guy, like a bunch of them. So I'll start first. All right, I'll probably just do everything, right? So I'll just bring it sufficiently such that this face and that face are tangent. Very good. And I'm gonna make like a sequence. That way it's like a nice reciprocating structure, right? That they're all they're gonna be moving in uniform. And okay, that guy, I'm gonna make this towards there, and then I'm gonna make this like that, and then this and this, I'm gonna make tangent, and I want this to be slightly, ever so slightly higher. That way it looks like a nice synchronized. Well, this one I'm gonna put it just a tiny bit higher like that. Let's go to number 4. And I'm gonna extend all of these sticks, by the way. Like it's gonna look nicer. Relatively simple design, I'll say. I can make it look prettier as well. You see, like now I don't need to flip the orientation because the orientation doesn't matter much. I do this face and that face. I do tangent. It's always gonna be constrained as far I think it's mostly gonna be constrained to that position. Maybe this can make it go slightly downwards. So there we go. Okay, almost there. Let's add four more. Right? It takes a little bit of patience to do this, but that's what we're here for. To make cool stuff, to CAD almost anything, like one would say. And here, okay, so we're gonna touch this face and that face. Yeah, that's as high as that's gonna get. I have a lot of faith that this is gonna work. The only problem is that as I do modify the original design, I'll just have to be careful to preserve that central column, the one that I drew originally on Astro, and you'll see why all of this effort is gonna be worth it in a second. In essence, I pretty much everything that's gonna come after this, which is the speed cut video, it's just pretty much optional. Because this is, if this works, then everything else is just extra. It's just beautifying it, making it look a little bit prettier in terms of color. And two more insert components. Made. So now you can pretend you are an Imagineer that works at the parks, right? Designing all of these different attractions. And mate this guy and that guy. And another design constraint is that we need to make sure that whenever this works, that we're never like this has to be sufficiently tall, right, for one of the configurations. So we'll see how we make it. It's possible we might change the design. Like we'll see how things work out. So I'm gonna put this guy in there. Mate this face and that face. Make it tangent. It goes like that. Okay, good. We're gonna save this. And now I'm gonna float this. And the reason why I'm saying this is because now I'm gonna insert Astro Orbiter number 4. And this one in here is the one I'm gonna fix. And I'm gonna mate this face and that face. And I'm gonna bring this. Oh, let's see if I made and there. I don't want to touch yet any one of those gears because I want to make them all together. All right, so that's good. I'll be saving this. And here's where the magic happens. Mate, we're gonna do gear mates right here. So I'll be mating each one of these individually with that guy in there. So I'll say, all right, I want that face and that face. Yeah, whatever ratio, I don't know, I think that's fine. So I've done that one. Then the next one is this face and that face, gear mate. Then the next one is this face and this face, gear mate. The next one is this face and that face, gear mate. The next one is this one and that one, gear mate. And so I think that's number 5, which means, all right, face and this face, gear mate, 6, this face, and this face, gear mate. All right, so how many have we done? 7, okay. I'll have to check them all, gear mate. Uh, and that face. I'm sure I messed up somewhere one of these, but we'll see. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 7, 8. That one was down. Okay, that seems fine. The question is, if I were to now bring this downwards, right? So here's where the magic happens, right? If I were to spin now, so now here that it's gonna be changed. So I'm gonna constrain this face and that face. Coincident, right? Okay, now yes. So if I spin this, all of these guys, maybe you don't see it, but you should see how the wheels are turning around. Like the things are going up and down. It is a little bit slow, but I think that's fine. It's that's the way it's supposed to. That was not a terribly like the ratio is not terribly high. So it's true that one revolution of this, maybe I should maybe increase the gear ratio, right? In fact, if I go over to say gear one as an example, right? Having an artificial change such that so it's 50 to 30, right? So one revolution in here, let's say one revolution here, which is the 30 to be I don't know, let's say 20 as an example, right? I wonder it's a lot of a I think it's a quicker turnaround if I were to do that. Yeah, I can change all of them. I can change them all to be actually 10 as an example. Maybe 20, 10, but I think once I start doing like once this I put like a nice torque motor to this, it's probably gonna right, so let's edit all of them. Good. 5. So now what all of this means is that I cannot get rid of that gear. I'll probably have to leave it for a while. 6, 20 in there. 7, 20, and 8. Very good. Okay. So now let's go to so it's adding motion. I'm gonna click in here. So let's see moment of truth. Like does this work? So we go here motion study, new motion analysis. I'm gonna put say 10 seconds as an example. I'm gonna move our friend the bar. This will end up actually doing later, like, but this is just to get an idea of whether this works in here or not. And then you go over to our friend the motor, and what you're gonna say is, all right, I want rotary motor component. I don't think it's this is what I wanna rotate. I think I wonder. Okay, that's good. I'm gonna say 100 revolutions per minute. Um, say I wanted so 60 RPM. All right, so 6 RPM. That would be one revolution in 10 seconds. I think let's see what this number gives us. Right, I'm not even sure. That is too quick as I thought it was gonna be. So it's good sanity check. So I'm gonna. It is doing something which is good. Um, I wonder. I'm gonna go right here, edit feature, 10 RPM. And I have to go over here where it says calculate the motion study again. I think 10 might still be too quick. Let's see. I mean, towards the end, it does a little bit of a nicer. Let me create a new motion study. Why not? There's never enough motion studies. I'm gonna do 10 seconds in here. I'll move this guy over there. So this is important because we'll know it when we do another one later on. I'll select here. Let's do 10. Okay. And it's doing the sequence that we wanted to do. this is gonna look nice, like, when it works out. To have all of the rockets going up and down. This is great, right? So sanity check wise, this worked out as a nice proof of concept. This is we're gonna beautify Astro Orbiter 4 in a moment, but at least it's good to know that this is working. So I'm gonna save it. So now the idea, like the idea and idea the plan of attack is just to make this look prettier. That's it. And I might actually leave like these circles. Leave them visible. That way people can see like the. Maybe I can beautify a little bit this stuff, make it just like so that people can see right. This is like what it's doing, but otherwise we're just gonna probably play it by ear. Try to make a nice design out of all of this. Um, yeah, so like the whole approach is that yes, we're gonna do all of this structure, and like just build it out from scratch. And you see, like a lot of it happens like so. Astro Orbiter 4, as you can see, it's like that would be that column in there. So I'll probably start by doing that. But otherwise, I think it's gonna be pretty simple. So I'll speed up the video from now onwards as I just CAD all of this, but I'll be referencing mostly these pictures, just trying it to look as closely as possible to the actual thing. So yeah, so we'll take it from there. And yeah, thank you, Raj, for watching. Yes, feel free to post it as you go. I might come back at the very end once I've finished assembling everything. So yeah, so let's do it. Alrighty, now we're done with the assembly, which means we can do a motion study. So I'm gonna go here to model, actually motion study. Yeah, yes, whatever. That's good. I'm gonna create a new one, create a new motion study, which is gonna start right off from here, and we'll do it 20 seconds, and we can make all of this. I'm not sure whether maybe I'll just move the camera a little bit, but this is gonna be nice. Remember to go here to motion study, and then we know that 10 is an appropriate time. So we need to select here, and I'll say 10. Okay, let's see what does this do. It is rotating in the wrong direction, so I need to move this. I kind of knew that that was gonna be the case, but we'll change it in a second. It looks kind of neat, lit, right? Like all of the different rockets just moving around. It's pretty nice. Let me see whether I can go to rotary motor, edit feature, rotate like that. Let's see if we can generate again. Okay, now yes, it is generating the correct motion. Wow. This is exactly what I wanted to see. Fantastic. So now that we've done this, we can now go to orientation, disable camera view. There you go, like here. Maybe something like this. There. Maybe end right here. And I'm gonna pan right like this. Okay, let's see where does this take us. I might get rid of that diamond. I'm curious to see how this is gonna look like. Hmm? Okay, this is it, folks. Thank you very much for watching, and we'll continue in just a moment with this Spaceship Earth. Alrighty, hi folks. So now we're gonna cut the EPCOT sphere. And as you can see from here, well, I was already trying before I started this video. I was doing another video where I had originally attempted to cut the sphere, and I was extremely unsuccessful until I kind of got to this point. So for those maybe not familiar with EPCOT, like the spaceship Earth sphere in particular, it is a geodesic dome. And a geodesic dome is essentially taking a sphere, right? Just a regular, like you would do a revolving sphere, and trying to mesh it all out using equal sized triangles. That's what we have in here. In fact, I have a couple of pictures. Well, this is I'll explain what that is, but if we go here to EPCOT sphere, oh, here we go to images. That's essentially it. It's a lot of equal-sided triangles. Well, you'll see, we look a little bit more at the details. Then every one of the triangles has a little bit of an extrusion there that we're also gonna model. We're gonna get to that level of detail. I'm not sure whether we'll model all of the triangles. We'll see how much patience we have, but definitely we'll try to get to something that looks pretty similar to this. And the point about the EPCOT sphere is that you start from a shape as simple as this. So the strategy to get to, let me just go back here to SolidWorks, to get to this is to get to the most basic of shapes and then subdivide it and then subdivide it and then subdivide it into even more triangles until you start getting something that looks roughly as a circle. And I'll explain all of this as we go. Yes, I had some failed attempts, as you can see in here, in making the sphere because I wasn't quite understanding the geometry, but now I think I do. And the key to this is to design this shape that's called an icosahedron. I guess that's the name. Icosahedron, which is a 20-sided polygon. As you can see, and it's relatively simple. So it's like a pentagon on the side, pentagon on the bottom, and then like, to the side you have 10. And then just looking at here at some, like I found this PDF pretty good if you want to reference it later, that essentially tells you the whole procedure of how you build the geodesic sphere, in the sense that this is the icosahedron, this shape in here. And then what you do is you draw a circle that essentially chops this and like that just goes through the edges. And then from there you draw a little triangle, and then you draw a triangle there, there, and there, and you fill it up. And that becomes your new subdivision. And then you repeat that same process on that little triangle, and so on and so forth. And that's how you're able to extend this. You can see there. So I'll explain this procedure now. So let's go here. Yeah, I've got sphere, and then I have multiple shapes in here that I've been trying. This one is called Spaceship Earth. In fact, this one probably, I think I'm gonna, let's see if I can delete uh, everything. Mm, because I want to use the same file. Wait, let me see it again. So the general approach when I'm deleting all of this stuff, I can go explaining, is that we're gonna do surface modeling, but to do surface modeling, we have to create a mesh. And creating this mesh, now that I struggled enough by myself, is not too difficult to do. So the overall procedure, at least to get to this sphere, it's maybe like a 20-minute procedure, it's not too long. Maybe as we go extending this, it's gonna be a little bit more complicated. So let's go. It will require a little bit more patience. I'll just delete all of these guys. All right, we're almost there. Because I want to do it tidy from the beginning, right? Yes, and there's going to be a lot of mirrors and symmetry that we're going to exploit. There we go. Okay. Now we got yes to all. So let's start doing our EPCOT space repair. So we'll do a sketch in the, yeah, right plane, whichever. I don't care which one we do. And then I'm gonna draw a pentagon. So just clicking in there from the origin. And this is gonna represent kind of like the top side. Let me add a center line in here. And for now, I'm gonna decide that I'll make every side be 100. Boom. And that's it. Exit sketch. Now the key in here is to go now to 3D sketch. And we're gonna draw a bunch of lines that come like this. In fact, I'm gonna draw, there we go, 5 lines. I'm gonna join them all like this. And the idea is that I'm gonna click on all of them, just like that, and say equal. And then I should be able to make one of these lines also 100. In other words, this shape has, all of the edges have to be the same length. Exit sketch. So now to draw the other part of the, here's where I struggled earlier, but I think now I figured out I'm gonna draw a line that extends from here. So the 3D sketches are extremely useful in terms of like how, if you know how to use them properly. So we go to the, oh, not the word, sorry, right here, and that is not where I want it to be. If I go here to icosahedron, you'll see that Yes, you have that edge, and then the pentagon's edge is right beneath it. What do I mean by that? That here's what I'm gonna do. I'm gonna draw a line like that. Then another line that's gonna come. It's gonna go. Let's see. Yeah, upwards. Oh, actually, hold on. So I'm like that. Yes. So there we go. I want that line to go center line upwards, and then I want to go like that. Okay, perfectly. That's how much I wanted to do. So, so from here, then I'm gonna draw a little. I'm gonna finish the triangle like that. So what I want to do first is I wanna well make these two equal, obviously, and I also wanna make this be 100. It's still not fully defining everything because we need to determine, all right, what is the length of that line? Well, it's not too difficult to determine because we know that this is that length in there has to be equal to, if I'm not mistaken, if that's the pentagon, that has to be equal to 50, if I'm not mistaken. Yes. Yeah, that should be correct. Right, because then when we do finish that triangle, uh, there's gonna be another triangle coming in there, and that should complete it at, yes, that should also be 100. Yes, if I've done the math correctly, I can just exit that sketch, and then I can create another plane that's gonna go right there. And now in that plane, we're gonna do another sketch. And then, yeah, so that everything should work out. Now I can do another pentagon, but you'll see that this one, there we go, just like that. So I'm gonna complete that line in there, and I'll make my pentagon exactly 100-sided, and I can make those two perpendicular, that way it is all fully defined, and voila, that's good. I can exit the sketch, and in fact, I can just go here to 3D sketch. I can finish, there we go. You can finish and you see that all of the lines, if we've done the math correctly, all of the lines have to be 100 long, and that's good. But that's how you can make sure that the shape is appropriate. There we go. Excellent. It's not a, we don't need a lot of this stuff to be honest, but it's good. It's good to have the full layout in here. And then I'll do another 3D sketch, and I'm gonna replicate the exact same stuff. Oh, the 3D sketches are pretty versatile, as you can tell. Oh, you have to be careful with. I'm not gonna make a lot of use of them, but there we go. And then one more line is gonna come right here. Then yes, this looks like a big mess, but I can make all of these lines equal. And I'm gonna bring this up. There we go. Excellent. And then I'm gonna make that 100. So now we have exactly our shape. So regardless of the direction that you see it from, so it's equivalent if I see it from there and whatnot. So I can just exit the sketch. Boom. Not much else that I need from here other than the following things. What I'm gonna do is go here to surfaces, which I just clicked on surfaces to add in here. And then I go to fill surface, and I'm gonna, let's see, actually, I'm gonna go here to 3D sketch, and I'm just gonna trace just one triangle. That one, like that. I might need more, but let's start with this one for now. And then when you go here to the surface, I can fill all of this up, but we're gonna do the minimum effort approach in here. I'll just focus on that one. Oh, I might need these three as well, actually. So I'm gonna draw them out. Actually, not really. No, I do not need those. I'll need a plane that will go on those ones later. But I'll leave this triangle right there perfectly. And then another thing that I'll definitely might need is a line to do some symmetry, but I think I'll leave this for now. Okay, so now I'll go here to features, reference geometry plane, and I'll create a plane that's gonna go there. Then I create another plane that is gonna go here. And then another plane that's gonna go there. Good. And the reason why I'm creating these planes is because now here's where we start the process. If we go to our PDF of exactly create these are the planes that we will be creating now to be able to create our little triangle that's gonna go in there. I think, let me just make sure that these planes are correct. Yes. Think for a moment. Actually, no, these are not correct because I need the planes to be pointing outwards. And I'm gonna get rid of many of these lines in a moment because we might not need all of them. So I need a plane that's gonna come out in that direction, right? And the way to do it is by clicking in there and then I click in this point. There we go. Now, yes, that is the plane that I need. You see, it's tricky. And now I'll click on that one and I need this line right there. And now I'll do another plane where I click on that line and I click on that point. There we go. So what I'm gonna do for now is that I think it might be worth just hiding all of this stuff because it's confusing. Oh, it didn't work. Hide. Okay, but I'm gonna keep these planes and you'll see how we're gonna be employing them in a moment. So I'm gonna go here to, oh, now actually I do need all of this stuff for a moment because oh, I do need to show everything again, but I do need to draw one more line, a 3D sketch that can go, say, from here to there as an example. I'm gonna make that a construction geometry because that point right there is the middle of our figure. And now, yes, I can exit this and I'm gonna hide everything but that line, this stuff. Okay, now, yes. So I'll go here to sketch, choose any plane, say that one. And what I'm gonna do is very simple. I just draw a circle. It's gonna go, actually, I'm just thinking for a moment. Maybe I could do it as a 3D sketch, maybe. There we go. No, it's just that it's not constrained to, no. I choose this plane. Maybe if I convert this line in there, there we go. That should work. And now, yes. You see how this circle touches both those vertices in there, and that's exactly what we want. Now I'm just gonna complete this shape by making a line that's gonna go like that. Boom, exit. So it's easy as that. Now we do the same procedure on, say, that plane as an example, right? So we need to find again that origin. So I click in that point and then I go all the way there. And just as a sanity check, I'm gonna show you something that will help us confirm that our math is correct. I exit. And now we do another sketch on that plane. There we go. Do another circle that's gonna come like that. Make that a construction geometry. Then I go all the way like that. If I were to draw a center line that goes from here to here, if I've done my math correctly, but I remember the numbers from the first time I've done this, that is All right, 14.2. Remember that number. So 14.2. Okay. So I'll exit. Now I'm just gonna hide all of the planes because I've already used them, and I've created exactly the triangle that I need to create right there. If I go to here to edit that sketch, and I draw again this line, if I've done everything correctly, that should also be pointing 14.2. Excellent. Very good. And now let's check on here. Last sanity check is that 14.2 as well. That is 14.2. Excellent. Okay, so that's good. It all checks out nicely. And now what I can do is another 3D sketch where I am going to be connecting those films. Then I exit that 3D sketch and I go here to here fill surface. So now I'm going to start filling up all of these triangles. So we're going to make this pretty quickly like this. I just go like that. Oh, that one is not correct. Boom. I exit and then I fill the triangle, 3D sketch, 1, 2, or not there, just like that, fill. This is how we are building the structure. So we're gonna repeat this process in one of these little triangles. We'll see how exhausting that's gonna be, but at least this is gonna get us to where I started the video from. And now we go here to freeform. There we go. Now I can actually hide these sketches. I don't need them anymore. Hide. Good. Well, I'm gonna actually I can hide that one too. I can now go here to 3D sketch. We need to fill this entirety or all of this piece, and I'll show you why in just a moment, because there's a command on surfaces that's called knit, which essentially brings all of these together into a solid. So making this without surfaces might be a little bit difficult, to be honest. Although this is, in my mind, it seems like the easiest way of being able to draw this. So I go like this. And then there we go. Fill. And then there is here knit, where I just select all of those guys, create solid merge entities, boom. So now we are at this point, which is pretty good. And now, because all of these are curved, what I can start, so first let's save this. And now I can go here to my friend mirror, and I can say, all right, I want to mirror around here, bodies to mirror, say this. I can do that, or yes, I'll actually do that. I could also have traced it along an axis, but I think I'd rather just manually mirror all of these guys. And technically speaking, I should be able to, there we go. So now one more that I mirror, and that should be enough to complete this. We'll see. Now here, and then bodies to mirror, say that one as an example. Let me go here to mirror face, bodies, I'll say that guy. Uh, oh, it's merging the solids, and maybe I'm gonna leave them as unmerged for now. I'll go over to so I wanted to do that, and then bodies, that guy. But don't mirror them yet. There we go. Okay. And I go here to mirror face. There we go. So at least it's working out. So I'm getting something that attempts to be like the sphere. I'll save it and I'll leave it as individual pieces, right? Because then I can go here to mirror, and then I can say, all right, mirror plane. I can say that, and then bodies to mirror. Well, why don't you mirror like all of them, right? And now let's say mirror. Let's say I go for that one, and then bodies to mirror. But what about that one? Actually, I think I can select yes individually all the ones that I want. So now we've essentially completed this piece, right? So I can now go again to mirror, mirror face. I'll go to mirror maybe. Let's see. Actually, yes, that control that is completing, right? Our shaping here. So then mirror, mirror face, body is this, and then mirror here, body is this. Boom. Okay, so we've gotten this far, but I want to do, let's say, one more level of subdivision, right? So this is pretty good. And now we have to repeat the same algorithm that we've done, but we're gonna do it on this little triangle right there. And in fact, all of these mirrors that I've done might not actually be necessary. This is more to, as a proof of concept to see that, well, we can form one geodesic sphere. And then, so we'll do the next one. So now we need to show again this 3D sketch. I need it because that is our, I suppose, our center line right there. And so now to find where, okay, so I need to find where the plane, we're gonna do the same approach. So I'm gonna create 3 more planes. So say that is our face of choice. So I need a plane that will go like that. Then I need a plane, I'm gonna do another plane that goes, oh, a plane that goes from here all the way there. So it's as if it's right perpendicular. There we go, that one, we got that one, and we need that one. So another plane that's gonna go from here all the way. Actually, could I think the line should work. Okay, let's try again. I think I was referencing the previous plane. There we go. Excellent. Okay, good. So far so good. So now we go back to sketch. Go to, oh, I don't even know which phase we are working with right now. But the important thing is that I need to find the middle of that line. So I'm gonna go here to convert. I'm gonna convert that line. Regardless of where it is, at least I know it's there. I can just draw. Where are we on? Here. Okay. So now you see how the circle is even smaller and smaller each time. You know, this is approximating way better our sphere. So now the number that we have to remember is 4.654. Okay. That's it. That's how we know whether we've done the math correctly. Now we'll do that plane. Now we go back to circle. Let's see. All the way there. Construction geometry, because I only want to highlight this area right here. Then we go like that. And then if we go downwards, what we get is 3.61. I see. So maybe I may have messed up one of the areas in there. Hmm. Let me see what do I get in that one. Unless I messed up the creation of the plane, but we'll see in a moment. I could, I'm gonna actually, I'm gonna hide some of these guys because I cannot see well otherwise. There we go. So the one that we want now is, let's see, hold on, which ones did I? I need that guy again. Okay. So it's this plane, the one that we are interested on. So let's see whether we can do this appropriately. Okay. I'm gonna make that a construction geometry. Let's see what height do we get now. So 362. Okay, so we got two 362s, which means that maybe that one is not correct. So I'll have to check this one again. I'm gonna delete it. And I'm gonna try again. I have a feeling that if I delete this line, it's not gonna be happy. But we'll see. Let's just try one more time. That looks, yeah, like it's mostly fine. Alrighty, so now there we go. It took a little bit more work than I thought just to get to that proper subdivision, but it was just a matter of doing this properly. That was it. And now, yes, I should actually show this guy and that guy where you can see it. So I got 465 on all of them. So now the procedure is quite easy. We repeat the same usual triangulation, And I might actually hide this body from here and then from there just try to. I think this is as much as much triangulation as I'll do because it will probably get overwhelming. I have a feeling. Oh, where did we go? Well, from here. Pretty scared. There we go. We do the classic three lines in there. So that's 30.9, 30.9, 30.9. So we have to make sure that these are all fine. Yeah, so that's probably how it will end, but you'll see that once we start doing all of the spherical pattern, it's gonna look quite nice. So I'm gonna leave it like that. And then if it doesn't, then I might consider one more degree of triangulation, but we'll see. Because then from these tiles, right, that's when we do the EPCOT effect, which I might actually do it in a moment, honestly. So I'll just draw, I'll exit for a second. Here, 3D sketch from this point to this point, like that. And now we go do fill, excellent, 3D sketch, another one from here, do here, like this. So it's an intricate design, right? It makes you appreciate all the more. Oh, there we go. One more time. How Spaceship Earth was designed, especially in a time when perhaps CAD softwares like these ones were not as readily available. So it's impressive to think about just also the mathematics behind these concepts. There we go. So now I'm gonna hide that, and I'm gonna hide all of these because I kind of already have all I want. Yes, and I do have the triangle, which is what I need. That's the most important part. So now I'm just gonna finish doing the classic in here, fill. Then I'm gonna add 3D sketch, and then essentially we're gonna pattern of this kind of manually because I don't want to use any circular patterns yet. I'll do that with the mirror. It works. It worked decently. I'm gonna save that. Just that we need to add the little details on the tiles. In the 3D sketch, like that. We're gonna close that. Boom. Then last but not least, 3D sketch, triangle right here. I think probably EPCOT, the level of detail will be the next layer up. That might be a lot of work. So I kind of do want to try to see how this one might look in terms of actually this one might be end up being the EPCOT level of detail. And now we go here over to actually before I do knit, I might leave this as is. And because I want to add the little triangles from here. So now I'm thinking what would be a good way to achieve that? I think I know. The answer is the 3D sketch. So we go like that, just like that, perfectly. And I say, all right, 1, 2, 3, equal. Um, and I'm gonna say that I want the length of these to be 15. Actually, can I? Wait, it's probably too little. Let's see, 20. No, 20 is too much. Let's see, 18. Okay. I think that's gonna definitely be noticeable. I'll make that construction. But what I can do is just finish this in here. I'll go here to exit, and that's where I'm gonna fill right there. In fact, I could, yes, I'm gonna hide some of these, and I'll finish doing the sketch. Yes, I'll definitely, this is definitely, given that I'm adding this detail right now, this is gonna be the final layer for the EPCOT sphere, but that's fine. I leave it as an exercise to the reader if you'd like to try one more layer of triangulation. By the way, what I'm drawing in here are, let me just go back to the EPCOT sphere. It is those little details, like there, see how it's coming out nice. In fact, I'm thinking that maybe I could make the height of that a little bit taller. It seems I'll go back to the very first one in a moment. I think it was that guy. Or maybe I'll make this 19. Or what about 18.5? Yeah, 18.5. Good. So now that we've done this one, I can do it over here. So I can go here to 3D Sketch. So it's a lot of surfaces. That's okay. There we go. And I say, all right, 1, 2, 3, equal. And then our friend that line, 18.5. It's definitely gonna look pretty for sure. I think this is gonna achieve the desirable effect. So I'm gonna speed up from here. That way you don't get bored with me doing this. Okay, this is one of the tiles. I'm gonna save this. So let's see where we go from here. So I'm gonna go here to features, mirror, and now mirror plane is gonna be this, bodies to mirror that, and we're gonna build it little by little, just like that. Oh boy, this is gonna look nice. I wanna make sure which with each one of the mirrors that I'm not merging good. Because I'll probably leave it a merge, and if I do merge things, I'll do it in the end. But for these large scale items, I think I'll probably. Oh wow, this is gonna look super pretty. I go here. What is in bodies? There we go. Oh, I should probably. Maybe I'll do mirror. Mirror face. I'll leave it like that then. Okay, so that one doesn't like it. So maybe I'll just do I'll do that one. Okay, that's not the end of the world. Mirror face, this, and then all right, this is where I think we may be facing a little of a problem. In fact, that is a problem right there. Oh, it's the fact that oh, evaluate. 58. Mm, 58. I think the angles that I'm using for the mirroring are not the correct ones. So I'll leave this as is. Right. I know what's going on. So maybe what I should do is go here to features, mirror, mirror face this, bodies, I'll do this guy. Right, so what I'm finding is that, oh, I might need either to replicate this on that shape in there. I see. It's not the end of the world, but I'm just trying to figure out why. Maybe the planes I've used were not appropriate for this. Uh, yes, I could maybe try to replicate all of this stuff on that polygon right there and try to. Hmm, I might actually. All right, I see what's going on in there, but it might be mitigated. So this, for some reason, it's 361 when that one was consistently different. So, and then we're doing the exact same procedure. So what I think I'll do is I leave that as is, um, because I'm gonna focus on this block anyways. I'm not gonna kill myself doing more than that. But at least we're gonna make now a pattern. So I'll try to have this block ready and then we'll do a circular pattern from here. So I think this idea might end up working in the end. I'll make that perpendicular. I'll exit. I don't need those planes anymore. Oh, this might work. Let's see. We go back to 3D sketch like that. As long as these faces are still correct, which I know they are because we just built the sphere with that. I'm gonna leave this like that. Yeah, so now it's just the tedious process of doing this again, like in this manner right there. So we go over here to 3D sketch, line, and we'll just go. There we go. Although just to be honest, I'm building these ones for now. I don't think I need to kill myself because then, well, actually, yes, I kind of do need to because I'll be doing a ton of surfaces as you can see right there. Should go like that. Boom. But it's good practice, right? On seeing how you can leverage these things. I'm gonna hide that axis. I don't need it yet. But the idea is that I'm gonna make a body, and technically, I should be able to rotate all of this around. If not, that would be devastating. Um, in that case, I would need to rethink the strategy. But I think it's gonna work. Now with the free sketch, where I do need to, there we go like this. So technically, yes, these three should be the same. Free sketch like that. In other words, one of these pads holds a ton of triangles. So that's how you can realize that, yes, our friend the EPCOT sphere ain't easy to CAD, or at least it takes a while. And the idea is that, well, this would be approximately the procedure that I would do. And this is just only focusing on one of the blocks, which makes sense because this is more of a prefabricated structure when you think about it, right? And there we go. I'm just gonna connect all of these with, yeah, that's fine. That's it. Okay, so now I can hide that. And now I'm gonna just hide all of these. Actually, no, not yet. So I'll do triangle by triangle. So 3D sketch, and now we have to go all the way like this. All of those equal. Then just like before, 18.5. Right, so maybe because of the differences in sides, I may need to make that smaller. Let's see. It's gonna be interesting. I think I'll use 17.5 for this. There's probably somewhere where I messed up the math. I'm pretty sure. Well, it's hard to debug all of these structures. Good. Now we do one more. Okay, this doesn't look bad at all. The question is, can we combine all of this stuff? Let's see. That way we can deal with them. Okay, and let's use this guy. Okay, that's good. So now we have our tile, which means that now what remains from here should be easier in the sense of now it's all about mirroring this over and over and over again. So I can go to this face and I want to mirror body. So I go like that, and then I can go to mirror. Actually, let me just make sure with the mirror that I'm not combining because I do not want to merge yet, as I always like to say. Yeah, this might actually be the level of detail that EPCOT is. Maybe they even realized while they were designing this that it was too difficult. Okay, good. And now here's the moment of truth, right? If we're able to finish to close the dome, it means that the level of detail that we've done is appropriate and just like the math worked out. If we're not able to close this, I hope we are, then yes, we would be in big trouble. But we're able to do it. Excellent. Oh wow, this is gonna look great. I'm even impressed myself that this is working because sometimes, more often than not, this is actually quite challenging to do. Voice to mirror, I'll do that. Yeah, I'm wondering, can I do all of it? Yes, I can do. Oh, fantastic. Great. All right. And now I'm gonna mirror, let's say mirror face that. Then bodies to mirror like that. Boom. Okay, it might be, now that I'm looking at it, it might be a little bit of a smaller version of the EPCOT sphere, but it's still, quite good for what this is worth, right? In terms of the level of detail. Maybe one more layer of, I think it would have been one more layer of triangulation, but this is fine for making it the return on investment, as one would say. No, and I'm gonna mirror this one around there, and then I'm gonna mirror. It's just that it is a lot of work to add all of the different details in there, and then one more to finish up. Wow, and it looks kind of neat in the interior too. So it's all, we started with math, right? All of this triangulation right there. Boom. This is great. When I save it as, I guess, our version of Spaceship Earth, and then we could combine all of this. Let's see. No, it's not gonna let us. Yeah, that's why I didn't wanna do it from the beginning, but that's fine. Well, now the question is, where is our bottom plane, right? Which is somewhere around there. Okay, so we go back to a picture of EPCOT. Yeah, so you can see in EPCOT, yes, it's definitely one more level of triangulation. So this is, again, I just want to be clear that it's a lot of work to get to this level, but at least it has those free legs that are coming from the side. So let me take a look from here, that are coming into the. So we're gonna try to model those free legs that are coming in there. So now I'll go here to sketch. No, actually not from there. Go plane. Let's see whether we can do flip offset a little bit more than that. Let's say 50 perfectly. And now I'm gonna go here to sketch. Oh boy, now we need to figure out what is the. I think it's that point in there. Let's see if I can convert entities. Say those two lines. Just go like that. Let's say we want to make that a radius of. Actually, that's too much. 280 maybe. Alrighty, so now the last step, I already placed the spaceship Earth here on the theme park, but well, the last step is to just finish this up, finish putting all of our projects, and the last one that remains is the Astro Orbiter assembly, which I'm gonna bring right here. So I need to turn this around. So this is gonna be fun because I think I have a feeling that I'll need to save this as a part, and that's fine. I'll probably, for these purposes, just for assembly purposes, right? Like if you want to work with the Astro Orbiter, like assembly specifically, I would recommend this, but just to include it in the theme park, I will save this as a single part, assembly part. And say on, click on save. And the reason why we're doing this is because this allows us to scale everything once this is saved as a part. Yeah, sure, whatever. And I need to scale this in particular. Like, I think I need to make this. Yeah, that's fine. I keep the original open. Okay, so I'm gonna go here to assembly part. We're here. And now what I can go is go to scale. It's all right. I want to scale everything. So we'll need to be just clever about, I think Centro it might be okay. If not, we'll have to go for Origin. Yes, I'll have to click on Origin in here. Otherwise, things don't scale properly. There we go. So yeah, we're probably gonna leave this in this configuration. In other words, in the theme park, and I'm gonna just delete this Astro Orbiter from here. I'm gonna bring the part version of this. I'll make it a little bit bigger in a moment. Things do not move, but that's fine. Like that's not the. I'm just gonna leave that in there, and I'm gonna place that guy in here, and I'll make this and that concentric. Boom! That's very good. And then I'll just continue making the Astro Orbiter part a little bit bigger. So that was 2.5, which means this is what I'm gonna go for 5. Let's go over to theme park. I'll say yes. I think that's gonna be about right. Yes. Then maybe I'll just place it like that. Very good. So this is it. This is our This is how to CAD almost anything, the Disney edition. I will make now one quick video to finish this up. But folks, thank you very much for watching. I hope you enjoyed all of these sessions and that you can use this because I'm going to put this whole online for you guys to download and do whatever projects you'd like to use with this. Maybe put it on virtual reality, who knows. But thank you very much for watching and we'll see you next time. We'll see when that is. But continue CADing. Happy CADing. Bye bye.